Now, right now in the LangChain documentation, if you probably see the recent updates that are there, mainly most of the modules revolve around this particular topics in LangChain. Okay, so over here you'll be able to see Langsmith. Here you'll be able to see Langserve. If I talk about Langsmith, recently I had also made a video on this, just a simple video, but I will try to create more videos on that when we go in this specific series. So Langsmith is, if I probably give you some examples, it'll help you to monitor your application. It will help you to debug your application. So in short, whatever MLOps activities is specifically required with respect to monitoring, deploying, debugging, testing, so third point I will say testing. You can specifically use this amazing module in LangChain that is called as Langsmith. The best thing will be that all the reports, all the analytics you'll be able to see very much easily in this ecosystem itself, in the LangChain ecosystem. So there is a dashboard in LangChain which you'll be able to see it. Okay. Now, how we are going to use this entire technique in some projects, we'll be seeing completely end to end, and we'll also be able to understand this. So if I talk about Langsmith, it is mostly of if I say LLM ops. Okay, so this part that is right now required in many companies, so that part will also be able to cover it. That is the reason why I like LangChain, because it is providing you the entire ecosystem irrespective of any LLM model. Okay, any LLM model. Now coming to the second thing over here, you have Langserve. Let's say that you have created your LLM application. You obviously want your entire LLM application in the form of APIs, right? Without writing much code. Yes, you can write the code from scratch with the help of Flask or some other libraries. But here Langserve uses something called as fast API. Okay. And because of this fast API, creation of this particular APIs becomes very much easy. So we'll be also able to understand it before the deployment. If I have actually created my own LLM app, how I can actually create all the services in the form of APIs, that we'll try to see with respect to the Langserve. Now coming to the next thing, there are some amazing concepts and important concepts in LangChain, from data ingestion to data transformation and all. In that, major topics are with respect to chains. We'll try to understand about chains, and probably in the next video, once I probably start the practical implementation, the first thing that I'm actually going to cover is with respect to chains. And I'm also going to discuss something called as agents and retrieval, right? Not only that, you'll be able to see there is a concept of LCEL. Okay, now in this LCEL we will be discussing, and this full form is LangChain expression language, right? So there are a lot of concepts that are specifically used in LCEL. We'll also see that how it is basically important while you're building, what all techniques it actually has when you're creating your own generative AI powered application, right? Along with that, there are three main topics also which I will be able to cover it while I will be discussing all these things, that is about model IO, retriever, agent tooling and all. These are concepts that you should really know. The main aim of this entire series is not to make you understand in theoretical concept, but it's more to understand how you can create amazing generative AI applications irrespective of any LLM model. Now see guys, one of the questions that I get from many people, hey Krish, I'm using this specific LLM model. I don't have OpenAI access. I don't have API access. Tell me what should I do? Let's say many people say that, hey Krish, I don't have credit card for OpenAI, right? Can you show me some examples with respect to open source models like Google Gemini or some other Mistral? What about open source models, right? See, LLM over here, as I said, LangChain is an amazing framework to build the entire application, and creating the best LLM is already a rat race. So if I probably say this is a rat race by tech giants, right? So Google will be competing, Meta will be competing, Anthropic will be competing, OpenAI will be competing. So you don't even have to worry about this, right? Whatever models will be probably coming up in the future, don't worry about this. The main thing is that how you can use this LLM app in a generic way to build any kind of application. So here, whatever model it may come, you just need to stay up to date, right? Which model has the best accuracy and all. That will basically happen over here, right? Later on, all the integration part will be completely generic. Okay. Now let's go ahead and understand the entire LangChain ecosystem. Like, what are the very important things? So this is the diagram that I have already taken from the LangChain. So as I already discussed, with respect to Langsmith, the first model that you see over here, we basically say it as observability, right? And with the help of Langsmith, you will be able to do debugging, playground, evaluation, annotation, and monitoring. When I say annotation, it's all about creating your own custom data set, which will require with respect to fine tuning or creating your Gen AI powered application. The next thing is with respect to deployment. And recently, right now, LangServe has actually come. It'll be in the form of API. So here it is written, right? Chains as REST API, whatever services you are specifically providing. LangChain soon will also come up with only one-click deployment mechanism. Once you probably create this entire APIs with the help of LangServe, the next thing is that you just need to deploy it. Okay. Then, and already I have created a couple of videos on Langsmith and LangServe, but don't worry. In this entire series, I'm going to again start from fresh, combine new topics and create a project. Okay. The third thing that you really need to understand is about templates. Okay. So there are different templates, reference application. With respect to LangChain, you need to understand these three important things: chains, agent, and retrieval strategies. So we'll try to understand how these things work, and understand, guys, you will be able to get the code with respect to Python and JavaScript. But my main aim will be with respect to Python, because in some of the article it was already said that AGI application is going to get created in Python. Okay. Then you also have some integration components. So we are understanding about the ecosystem, because all these things we are going to discuss in this specific playlist itself. So here you have model IO, here you have retrieval, here you have agenting tool. So retrieval, you also will be having features to read your data set from different data sources, how you can actually create vector embeddings and all are there, right? In model IO, you have various techniques with respect to model, chain, prompt, example selector, and output parser. And finally, you will be also seeing that we'll be focusing on this amazing thing which is called as protocol, which is basically coming under LangChain core. And here we are going to discuss about LangChain expression language, right? So there are some important concepts like parallelization, fallbacks, tracing, batching, streaming, async, and composition. Suppose if you say your best algorithm is probably linear regression, logistic regression, so usually in this particular scenario, the interviewer may ask you regarding multicollinearity. So first of all, what the question basically that the interviewer may ask, that how do you handle multicollinearity? Okay, so we are going to, this is basically the interview question that has been asked by the interviewer, and most of the time they ask this particular question, that how do you handle multicollinearity. Now guys, please, if you know this particular answer, please make sure that you write this in the comment section of this particular video. But just to give you a brief idea about what is multicollinearity, just understand, guys, if you have a data set which has many features like this, F1, F2, F3, F4, probably 4 features, and you also have an output feature. These features are actually called as independent features. Okay, these features are actually called as independent features, and this feature is basically called as dependent feature. The reason we call this as a dependent feature, because it is completely dependent on these independent feature. Now multicollinearity basically says that, what are the problems that may occur if these independent features are highly correlated between them. Suppose the F1 and F2 feature are highly correlated, more than 90%. Then this situation is basically called as multicollinearity. So you really need to answer, how do we handle this particular multicollinearity? One simple answer that I would like to give, one example. Suppose if you tell me to give one specific example, then that is nothing but correlation. Okay. So we can use correlation concept, and I can say that probably if two independent features are more than 90% correlated, I may remove one of them. This is one suggestion that we can actually give. And again, just tell me about the other approach that you all know. Again, guys, see, these all interview questions are the common interview questions asked by the interviewer. Suppose if you say, and many people say that linear regression is my favorite algorithm. And in this video, I'm going to probably discuss about the Gen AI project lifecycle. Now, since you already know that we are definitely going to develop a lot of applications specifically in cloud, from the basic data ingestion till the deployment. So it is very much necessary that you actually understand a generic workflow of the Gen AI project lifecycle. So let me quickly go ahead and let me go ahead and write some amazing things for you in this particular notebook, and I will be explaining you completely step by step how you can probably see or follow a project life cycle. And as we go ahead, there will be a lot many things that will be coming, like LLM Ops platform, and we will be working specifically with Azure AI Studio, AWS SageMaker Studio, and all. So definitely both the clouds will get covered. So before I go ahead, please make sure that you keep the like target of all this kind of videos till 1000. That will definitely motivate me, and I've been exploring many more things so that you get the right kind of guidance and knowledge. So let me go ahead and let me start the Gen AI project lifecycle. With respect to this Gen AI project lifecycle, I would like to make this entire lifecycle into 4 to 5 steps. Okay, the first step, that is nothing but, here I'm just going to write over here. It is basically defining the use case. Okay, so what kind of use case are you solving? Now this use cases can be a RAG application, can be a text summarization application, can be a chat bot. So based on different use cases, that actually depends on your requirements, your company requirements. So this is the first step. You really need to define the use case that you're specifically doing. Now with respect to this particular use case, we usually take this entire module into the scope part. Okay, so this is basically my scope, right? If I basically use a generic term. Now, once you define a use case, let's say that I am going to probably develop a RAG application. In that, I'm going to definitely use vector databases. I may have a lot of PDF files. I also need to probably convert that into a vectors and store it in some kind of vector store DB. So some kind of use case you really need to define, and all the requirements that is required in that particular use case. Coming to the next step, which is super important, because these steps will be involving two important things. Okay, and that is nothing but choosing the right model. Okay, the right model. When I say choosing the right model, here there are two different things that you can probably split this into. One, whether you are using, or you are probably using some kind of foundation models. So here I'm going to probably write whether you are using foundation model and solving a use case. So this is the one category that I would like to divide this particular module into. The other category is that whether you want to build your own custom LLM, right? Custom LLM. Now see, there are two things over here, right? When I say foundation model, foundation models are already those larger models like OpenAI, Llama 2, Llama 3, right? You have Google Gemini Pro. So these all are very huge foundation models. And for most of the generic use cases, you can directly use those kind of foundation models and you can solve the use case itself, right? Now, with respect to these foundation models, we can also further go ahead and do fine tuning, right? So let's say I have a foundation model which I am specifically using to solve my business use cases. On top of that, if I really want to make this foundation model behave well for my own custom data, then what I can do on top of this foundation model, I can use LoRa, Clora techniques, and I can probably fine tune all these kind of models. Okay, so this is one of the step. The second step that I have written over here is custom LLM. Custom LLM is nothing but it is building your LLM from scratch. Building your LLM from scratch, right? And obviously this one, there's a lot of benefit also if a company is building an LLM model completely from scratch for their specific use cases, but a lot of resources will definitely be required. We have to really take care of model hallucination, many things and all as we go ahead. But yes, I've also seen many companies developing their own custom LLM model. Okay, so choosing the right model, or what kind of models you're specifically using to solve this particular use cases, that becomes the second important module with respect to this Gen AI project lifecycle. And obviously, I've spoken about foundation models both in AWS you have, in Google you have, in Microsoft Azure you have. Currently, Microsoft Azure AI Studio specifically have all the access of OpenAI services. Obviously, it is investing a huge amount of money over there. Okay. Now, once you probably select the right kind of model, there are main three tasks that you probably do for going forward. Okay. So main three tasks. Okay. The first task is nothing but you can specifically use prompt engineering and solve a use case. Prompt engineering and solve a use case. The second task that you actually can do is nothing but fine tuning, right? Fine tuning. Fine tuning. So with the help of fine tuning also, you can probably develop your own custom LLM model, and on top of that, you can basically do it. Let's say you're completely creating your LLM model from scratch. One more important mechanism that you have is nothing but aligning, or you can probably say training with human feedback. Training with human feedback. And this is one of the very important step that is actually used while you're training your LLM models. How a LLM model is basically trained, I've already created a video in my playlist with respect to the LangChain and all, generative AI playlist. You can probably go ahead over there. Fine tuning, how to specifically do fine tuning and all, that also I've actually shown you. The reason why I'm showing you this generative AI project lifecycle, because tomorrow when I'm probably creating videos, or let's say in the upcoming videos when I'm creating videos related to AWS series, over there you'll be seeing all these particular steps going ahead. Okay. Now, once you probably do all the steps, the further step is something called as evaluation. Okay, evaluation is basically seeing that how your model is performing by performing all these particular steps. There are also different performance metrics which we are probably going to follow. Okay, these two steps I would like to combine and say something like this. Okay, so I'll say probably adapt and align models. Okay, so this will be the specific module that we specifically use for this purpose. Now over here your model will be ready, everything is perfect, you are able to solve the use cases. Let's say your performance metrics is increasing over here, so your metrics is specifically increasing and it is saying that now your model is ready. Now it comes to the deployment part, right? So with respect to the deployment part, I would definitely say deployment. Further, you also need to do a lot of integration with different applications. So I will probably say application integration. Okay, application integration. And here what we do, we specifically perform two major steps. One, we optimize models. Okay, I'll just write optimize and deploy models. Optimize and deploy models. Okay, and this deployment is specifically done for inferencing. Okay, and here is where most of your cloud platforms, here is where your LLM ops is used. You know, different inferencing techniques are there. One technique I've already covered with respect to a platform which is called as Grok, right? It uses an inferencing technique which is called as LPU. So it is always good idea that you should definitely know multiple ways of inferencing. See, at the end of the day, whatever models you specifically create, unless and until the inferencing is not fast, you definitely cannot use those things, right? So it is very much necessary that you know the idea of this module extensively, because tomorrow building all these things is very easy. Fine tuning is very easy, right? You definitely have a template, a framework, a data set preparation and all, and you can perform this particular step. So that is the reason in this series of videos you'll be seeing that how much I will be focusing on this LLM ops platform, right? And I will also show you multiple platforms like which can definitely make your inferencing very much good. So this is the most important thing here. Definitely we'll be using AWS, Azure, right? You can use all these things, GCP, and we'll see what all services they have specifically provided probably for the inferencing purpose again. But initially our focus will definitely be on AWS. Okay, then the second step, after we do the deployment in the application integration, what we do next is that we build a LLM powered application. LLM powered application. powered application, because your integration is done, your API is created. Now it's all how well you can actually build the solutions, you can solve different use cases and all. Now what exactly a power law distribution that we are going to understand? First of all, let's focus on this particular diagram, guys. A power law distribution usually looks something like this. You always need to remember one very important thing, that is your 80-20% rule. Okay, now if you really want to understand what is this 80-20% rule, first of all, you understand that the distribution looks something like this. So in the x-axis you have something, in the y-axis we basically have percentage. So this percentage is nothing but it is also called as a proportional unit. Okay, and in the x-axis it is also called as a relative unit. Okay, so I'll talk about it more, but let's understand some examples. So I really want to consider one example. Probably in a company, 80% of the sales are coming from 20% of the overall products. So here, if I take this particular example, in this particular case, my y-axis will be percentage of sales. Okay, and my x-axis may be overall products. Okay, I'm just taking this as an example. Now from this particular graph, it says that this 20% of the overall products is actually doing the 80% of the sales, right? So this entire 80% of the sales are actually done by the 20% of the overall products, and the remaining 20% of the overall sale is actually done by the 80% of the overall products. This is a very amazing example with respect to this kind of power law distribution. Very important. Okay, now let's go and see some other example. The second example I'd like to consider over here, I'll say that 80% of Windows crash, I hope everybody uses Windows, crash are because of 20% of all the bugs, all the overall bugs. Right? So this is again an amazing example. We can also consider this. Now, what is the main thing that you really need to note? Okay, here I can definitely write a relative change in one quantity. See this, based on this particular distribution, I can come to a statement of this: a relative change in one quantity results in a proportional change in other quantity. This is how we can actually define this particular power law distribution, guys. We can say that this power law, if somebody asks you in an interview, because this is also a very important interview question, they may ask you various examples. So if somebody asks you what is a power law, you can basically say that a power law is a relationship between two quantities wherein a relative change in one quantity results in a proportional change in the other quantity. This is a very important definition with respect to power law, and this is what it basically says. Now let us see some more examples. I'd like to consider, and you can also give two examples by pausing the video and commenting in the comment section. And I've seen like many people are actually giving some amazing answers. So let's see the third example. I may say that 80% of data scientists uses 20% of the overall software products that are available in this specific domain, right? This will be my third example. So 80% of data scientists with respect to 20% of the most common software products. Now my fourth example can also be like this. I hope everybody is interested in IPL matches. I may say that 80% of the IPL match, right, are won by 20% of the team. Okay, or 80% of the win of any match is actually done by 20% of a specific team, right? This is again one more example. Now you can give various example as you like, guys, but understand what is the understanding over here. You really need to follow this 80 to 20% rule. One very good example, with respect to oil fields. Okay, oil fields. Probably just understand that this is the entire area of the oil field, right? And after this particular area, there are also small areas surrounding this particular area, okay, where oil fields are available. Okay, so just understand that 80 percentage of the entire oils are extracted from here, remaining 20 percentage are extracted from this 20%. Sorry, 80 percentage are, just understand in this way, guys. Sorry, I just want to make this pretty much clear. Okay, suppose I have some area of land over here. Okay, and probably I have some more small areas like this distributed. Okay, here when probably a government used to find oils, right, most of the oils will be available in this specific area. So just understand that 80 percentage of the oils are available in this 20 percentage of area, and remaining 20 percentage are available on the surrounding areas. So this can be also a very good amazing example with respect to power law distribution. Okay, now it is up to you guys, come up with more examples and try to put that in the comment section. But one example for this power law distribution is something called as Pareto distribution. I hope everybody has heard of Pareto distribution, right? So this Pareto distribution is a kind of power law distribution. So let's understand about Pareto distribution. Now in Pareto distribution, you need to understand the graph looks something like this. Okay. Now we have already seen, yes, with respect to power law distribution, you will be seeing like this. You'll be seeing like this. Remember, the height of the starting point is basically defined by this alpha parameter. So as the alpha goes higher, the height also goes higher. Okay, as the alpha goes higher, the height also goes higher. Understand, guys, there is a very small difference between Pareto and log normal distribution. A log normal distribution usually starts like this, right? Whereas a Pareto distribution usually starts like this, right? This is a very amazing difference between Pareto distribution, probably a Pareto distribution and a log normal distribution. So here, if I take this specific example, this is basically my log normal, right? This is basically my Pareto distribution. And remember, this height that is basically there is derived from this alpha parameter. There's a very small formula with respect to this kind of things, but if I go and see the PDF for this Pareto distribution, based on this alpha parameter, this height is actually determined. Okay, why it is important? Because understand, many of your distribution will also follow this Pareto distribution. Now the thing is that I'll also be showing you like what more things, some more advanced things with respect to practical implementation with Pareto distribution. But understand one more thing, which is called as cumulative distribution function. So here the cumulative distribution function is basically represented by this graph with respect to different alpha values. Okay, that basically means cumulative summation. You're just doing cumulative summation with respect to the probability, and here you'll be able to find as the alpha value increases, you'll be having still more curve. This curve will be pretty much in depth when compared to the other curves. Okay, so this is the basic difference with this. So why I'm explaining you this, guys, because this is a very important interview question with respect to what is a power law distribution. You really need to understand 80-20% rule. You really need to give this kind of examples. I've given 4 examples with respect to IPL, with respect to 80% of the data scientists using 20% of the most common software products, you know, and 80% of the sales are coming from 20% of overall products. All these kind of examples will be pretty much handy when you are explaining in the interview. So guys, in this specific video, I will be talking about all the things that you really need to learn in order to master generative AI. Now this field has become really popular in the recent days based on the amount of research that big tech giants are specifically coming up with, you know, the kind of LLM models, LIM models, multi-models that is being created. If you see all the tech giants like Google, Meta, X, you know, which is owned by Elon Musk, and if I talk about companies like Anthropic, they are in a furious fight to probably develop the best LLM models. Again, they are trying to bring that kind of benchmark. And if I talk about other companies who are really looking for automating most of the use cases, are specifically using all this kind of LLM models or multi-model in order to solve the use cases also. So if you are already learning generative AI, then the plan, the roadmap that I specifically give over here will definitely help you out. Okay, so if I talk about generative AI over here, guys, two important things you really need to do and understand. Whatever things that I probably say, whatever skill sets that I probably say, I have already uploaded videos with respect to this. Every playlist will be given in the description of this particular video, but the way that how you should specifically learn it is very much important. Now with respect to generative AI, if I probably talk about, first of all, I really want to talk about prerequisites. Okay, so prerequisites is the most important thing, that and this prerequisites will be very much important. If you are skipping this, trust me, it becomes very difficult to crack the interview. If I talk about prerequisites, at least one programming language like Python, okay, you really need to be familiar with, because right now whatever frameworks and libraries are actually coming up with respect to generative AI, specifically with respect to LLM models, LIM models, even multimodal, let it be companies like Google, Meta, everybody is basically working along with Python programming language. So Python programming language is must. This is the proper prerequisites that you should really do. Second is obviously statistics. Okay, statistics is something that you really need to be good at. Okay, again, the reason why I'm telling you to study statistics and understand how you can apply it in a real world scenario, it is just for making sure that you answer all the questions in the interview, right? So one of the favorite questions that are specifically asked in interviews, let it be generative AI, data science, statistics will definitely be involved. Coming to the third thing is with respect to NLP and computer vision. See, now many people like to specifically work with LLM models or LIM models. So that is the reason why now companies are coming up with multi-models, right? So multi-models, okay, if I talk about multi-models, right, and this will basically be my base. Understand one thing is that if you are really interested to only work with text definite use cases, right, so at that point of time your NLP should be really strong. Okay, NLP, okay. If you are probably planning to work in image generation, video generation, all this kind of use cases, then your entire computer vision should be really strong. Okay, computer vision should be really strong. Now you decide, like I have an interest specifically to NLP, so that is the reason I most of the time I actually focus on the LLM kind of models itself, right? Computer vision, I have the idea, I know about object detection, I know about things like that, right? So since we are talking about prerequisites, so these are the two different categorization that I really want to do, right? So let's say if you are interested in NLP, then definitely NLP machine learning is important. In this technique of machine learning, you will be understanding what is word embeddings, what is text embeddings, what are the different types of embeddings itself. I hope you have heard about one hot encoding, bag of words, TF-IDF, then you have word to vec, average word to vec. All these techniques you should definitely know as a prerequisites. Again, why I'm telling you really need to know, because that will set up your base. Unless and until you don't know this, if you directly jump to generative AI, you can do it, but again in the interview it will definitely hamper. The second thing that you really need to master, right, as a prerequisite is in NLP deep learning, right? Whenever I say NLP deep learning, what all things you really need to learn over here, right? First thing, right, you really need to know about RNN, and along with it you really need to know about its variants. Okay, all its variants you specifically need to know, like LSTM, RNN, GRU, encoder, decoder, everything as such. And obviously after completing all these things, you really need to know also about transformers and BERTs. Okay, and BERT. Understand one thing, guys, since I have been uploading videos from past 5 years, every of these specific topics has been covered in my specific playlist. Okay, so in short, once when I say NLP, machine learning and deep learning, you really need to have a thorough understanding. How do you probably work with recurrent neural networks? How do you work with all its variants like LSTM and all? How do you whether you understand attention models or not? Attention is all you need. And right now most of the models that you see in the market, specifically with respect to LLM models, are transformer or BERT variants itself, right? So all these things you should definitely know as a prerequisite. And again, for all this I have already created a playlist. Let's say that you are really interested in computer vision, then computer vision, CNN and object detection is the thing that you really need to know in order to probably crack any interview, right? in order to probably crack an interview, because these are the questions that they specifically ask. If I talk about CNN, the variants of CNN, RCNN, this object detection techniques, right? All those techniques that you specifically have to do is learn all these things. I personally have a lot of interest with respect to NLP, so that is the reason you have never seen much videos that I have specifically uploaded with respect to computer vision. So again, my area of interest will again be this. I will keep on exploring this part. So once you probably complete the prerequisites, okay, and once you understand about some of the machine learning algorithms and all, then you come towards learning generative AI, or you can probably say, yeah, learning Gen AI. Okay, Gen AI. Okay, so with respect to this learning Gen AI, I definitely like to categorize this into multiple things. One, okay, first, second, okay, I'll just try to categorize this so that based on this categorization you will be able to learn things. Okay, what all things this categorization will be focusing on? Second and third. Okay, now if you really want to learn Gen AI or generative AI, obviously after covering this particular prerequisites, now the popular question is that, Krish, can I directly jump into this? Okay, you can, but in interview you will face a lot of problem if you don't know the basic things. Okay, if I ask you about word embedding, you will say, hey, I will be using Olama embedding, OpenAI embedding. If I ask you, hey, how does it work? How are all these specific models used? So if you don't know word to vec, how these models are used, then you'll not be able to answer it, right? So that is the reason you really need to be good at this. If I talk about learning generative AI, okay, first thing definitely you need to know about frameworks. Frameworks to develop, right? Frameworks to develop Gen AI application, right? Now, whenever I talk about frameworks, okay, and there are a lot of things that I specifically want to talk about it, okay. So some of the examples with respect to frameworks like LangChain, right? If I talk about Llama Index, if I talk about Chainlet, and obviously if you are following me, I'm making sure that I cover all these things. Okay, so I will talk about frameworks also. I will write it in below. Okay, so if I talk about frameworks, right, this frameworks actually help you to work with any kind of LLM model. So one is LangChain, the other one is Llama Index, right, and the other one is Chainlet. Along with this, you also have Hugging Face, right? So with all these frameworks, you can definitely work with any kind of LLM models. Okay, all these frameworks are super important. So this is the one of the thing that everybody should basically know about it. Okay, parallel learning, and this is the strategy that I have also followed when I had probably started a couple of years back. Okay, along with this, if I talk about frameworks, then the things next is LLM multi-models and all. Okay, along with this, when I say multi-model, again, it works with both text and images. Now here there is a huge competition, right? A kind of competition is there from all the big tech giants, right? You really need to understand which all performance metrics is better, because in a company that you go tomorrow, right, they may ask you that, hey, try to use any kind of LLM models that you have, try to use open source LLM models. So here I will also be writing open source LLM models, open source LLM models. Okay, so any of these particular LLM models, you specifically need to know how does it work, what is the performance accuracy, and you need to keep on researching on these things. Not only that, let's say there is a model as a service, right? Like AWS Bedrock provides you multiple model access in the form of API. So you should also know about that and how you can consume in that specific application. So start exploring all these things. Some of the examples are like OpenAI. See, if you probably see in my playlist, I've created videos on OpenAI. I've created video from Gemini Pro, right? Gemini Pro. I've created videos from Cloudy. So everything. Why I have created this? Just to make you understand how you can consume all this kind of APIs and probably start working on creating a chatbot application. The third thing from frameworks and then LLM, and then third thing, most important thing is nothing but fine tuning, right? And if I talk about fine tuning, techniques like Clora, LoRa, right? And how do you fine tune with different open source models also, right? fine tuning with open source model. And if you know, I've also created a video how to fine tune with the help of Mistral, Llama 2, right, Gamma model, everything. So open source model specifically helps you in fine tuning in an amazing way, right? So that is what many companies may require in the future, that hey, if there is an open source model, please perform the fine tuning and try to see whether our data is basically being able to accommodate or not.